Welcome back. In this video, we are going to solve a structural design problem that involves a column design using load and resistance factor design method based on eStructural Design Tao found on the App Store. Design a reinforced concrete rectangular column of 12 inches by 20 inches using load and resistance factor design that carries an axial bending load at strong axis with axial dead load of 250 kips and axial live load of 150 kips and moment dead load of 30 foot kips and moment live load of 15 foot kips. Design criteria as follows: strength of concrete 4000 psi, vertical bars 3/4 inch diameter grade 40, lateral tie bars ½ inch diameter grade 33, bar configuration 3 bars along short side, 4 bars along long side. The column carries an axial bending load with axial dead load of 250 kips and axial live load of 150 kips and moment dead load of 30 foot kips and moment live load of 15 foot kips. Given axial dead load equals 250 kips and axial live load equals 150 kips, the factored axial load is 540 kips. Given moment dead load equals 30 foot kips and moment live load equals 15 foot kips, the factored moment is 60 foot kips for an eccentricity of 1.33 inches. Enumerate input parameters required. Column name C6, floor designation ground to second, rectangular shape and lateral ties, width of column 12 inches, length of column 20 inches, steel covering 2.5 inches, unsupported height 10 feet, bar configuration 3 at short side and 4 at long side, vertical bars 3/4 inch diameter at grade 40, lateral tie bars ½ inch diameter at grade 33, strength of concrete 4000 psi, factored axial load 540 kips, factored moment 60 foot kips, and eccentricity 1.33 inches. Given 10 pieces 3/4 inch diameter vertical bars, the area of steel is 4.4 square inches with steel ratio of 1.8%, and the spacing between bars at short side is 3.5 inches for 2.75 inches clear spacing, and the spacing between bars at long side is 5 inches for 4.25 inches clear spacing. To get the nominal load and moment at E equals 1.33 inches, let neutral axis C equals 20.7 inches and depth of compression block A equals 17.6 inches. Given column length of 20 inches and steel covering of 2.5 inches, apply the computations below to get the following distances and force type of each layers of bars. D sub 1, 2.5 inches compression. D sub 2, 7.5 inches compression. D sub 3, 12.5 inches compression. D sub 4, 17.5 inches compression. Follow the given computations for stresses and forces of each layer. Stress at D sub 1 is 40 ksi and compressive force at 52.8 kips. Stress at D sub 2 is 40 ksi and compressive force at 35.2 kips. Stress at D sub 3 is 34.46 ksi and compressive force at 30.32 kips. Stress at D sub 4 is 13.45 ksi and compressive force at 17.75 kips. Given FC prime equals 4 ksi and stress block is 17.6 inches by 12 inches, the force of compression block is 718.08 kips. By summing up all the forces, the nominal axial load is 854.15 kips. Follow the computations below for final check of eccentricity at 1.33 inches. Given nominal axial load equals 854.15 kips and E equals 1.33 inches, the nominal moment is 94.67 foot kips. Check for adequacy. The nominal design axial load of 830.77 kips is less than the actual axial load capacity of 854.15 kips. and the nominal design moment of 92.31 foot-kips is less than the actual moment capacity of 94.67 foot-kips. Follow the given computations for lateral ties. Design recommendation as follows. Fc prime equals 4000 psi. Fy equals 40,000 psi. Column size is 12 inches by 20 inches by 10 feet. Vertical bars of grade 40. 10 pieces 3/4-inch diameter bar. Lateral ties of grade 33. Half-inch diameter bar 3 sets spacing. 5 at 4 inches. 4 at 6 inches. Rest at 10 inches. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.